Hello everyone, my name is Aishwarya Gupta. I welcome you on this platform.
Hi, in the previous video we discussed about sp3d hybridization and its shape with zero lone pair of electron. For the geometry of PCl5 we have discussed so far that its geometry is trigonal bipyramidal with 5 electron pair and 0 lone pair, and I have also shown you how to draw this. Like this we draw trigon and each chlorine atom will be at each terminal, and these two bonds are known as axial bonds, and these three bonds are known as equatorial bonds. Now I will show the angle between these axial bonds and equatorial bonds. For example, these are the axial bonds, so they are separated by 120 degree with each other. And now I will show the angle between equatorial bond and axial bond. These are the axial bond and this one are is our equatorial bond. So the angle between these is 90 degree. So we can say that the angle between axial bond and equatorial bond is 90 degree, and the angle between equatorial bond is 120 degree. And we there is a fact that axial bonds are always longer than equatorial bond. Reason? Due to repulsion. Due to repulsion of what kind of repulsion? Due to bond pair repulsion. What kind of bond pair repulsion? Due to axial bond and equatorial bond pair repulsion. So if there is a question that axial bonds are longer than equatorial bond, then the reason behind this is that due to repulsion. What kind of repulsion? Due to axial bond and equatorial bond repulsion, the axial bond are longer than equatorial bond. And we can also take AsF5. As means arsenic for the example of sp3d hybridization with zero lone pair. Now we will discuss the sp3d hybridization with one lone pair. So our example is SF4. Here central atom is again the atom which is least in number, so sulfur is least in number, and bonded atom will be fluorine. Now we will write the electronic configuration of sulfur, which is equals to 1s2 2s2 2p6 3s2 3p4. So our valence shell is third shell, so number of valence shell electron will be equals to 4 plus 2, that is 6, and electron from bonded atom, which is equals to the number of bonded atom, so will be equals to 4. Now we will calculate the electron pairs. So we have formula that electron pair is equals to half of the sum of number of valence shell electron in central atom plus electron from bonded atom. So half of 6 plus 4, that is equals to 10 by 2, which is equals to 5. So hybridization will be sp3d, and lone pair will be electron pair minus bond pair, which is equals to 1. Geometry will be distorted trigonal bipyramidal, and actual geometry seesaw shaped. I will tell you how seesaw is drawn. Seesaw can be drawn like this: SF, fluorine and fluorine. This is seesaw, and there is one lone pair present at the equatorial position. Now we will discuss the geometry of sp3d hybridization with two lone pair of electron. We can take ClF3 as an example, where chlorine is central atom, fluorine is bonded atom. We will write the electronic configuration of chlorine, which is equals to 1s2 2s2 2p6 3s2 3p5. So again our valence shell will be third cell, so number of electron in the third cell 2 plus 5, which is equals to 7, and electron from bonded atom, which is equals to number of bonded atom. So 3. Now we will calculate the electron pair, which will be equals to half of sum of valential electron in central atom, which is equals to 7, plus electron from bonded atom, which is equals to 3. So electron pair will be 5. Hybridization, sp3d lone pair will be equals to electron pair, which is equals to 5, and bond pair, which is equals to number of bonded atom, 5 minus 3, which is equals to 2. So its geometry will be again distorted trigonal bipyramidal, and its actual geometry will be T-shaped. I will show you how this geometry is drawn. We will draw this like Cl, F and F. This will look like a English T, and there will be two lone pair of electron at the equatorial position. So this is T-shaped geometry. We can take many examples for the sp3d2 with two lone pair of electron like ICl3, BrF3, BrCl3. There are many examples which are T-shaped, and now I will compare all the three geometries of sp3d hybridization. So sp3d hybridization with two lone pair of electron with zero lone pair of electron will look like this, that is trigonal bipyramidal. Now I will draw the sp3d hybridization with one lone pair of electron, which will look like this seesaw shaped. Here we use a central atom and here we use lone pair. Now I will draw sp3d hybridization with T-shaped, which will look like this, and there will be two lone pair of electron. So from trigonal bipyramidal, if we remove this bond, then we will get seesaw shaped. If we remove these two bond if we remove these two bonds from the trigonal bipyramidal, we will get T-shaped geometry. So these seesaw shaped and T-shaped are no other new geometry. These are just derived form of trigonal bipyramidal geometry to reduce the lone pair bond pair repulsion. Now we will head towards the next hybridization, which is sp3d2. The first example for the same is SF6. Again, central atom is sulfur, bonded atom fluorine, and electronic configuration of sulfur will be equals to 1s2, 2s2, 2p6, 3s2, 3p4. Again, number of valential electron 4 plus 2, which is equals to 6. Electron from bonded atom, which is equals to 6. So electron pair will be half of the sum of number of valential electron in central atom 6 plus electron from bonded atom 6. So it will again equals to 6. 6 electron pair means hybridization. sp3d2 lone pair 6 minus 6 0. Geometry will be octahedral, and octahedral is drawn like this. I will show you how it is drawn. We can draw octahedral like this. One bond is above the plane and one bond is below the plane. So octahedral can be drawn like this. Now we will head towards our new geometry sp3d2 hybridization with two lone pair of for example xenon tetrafluoride. We all know that xenon is a noble gas, so and fluor so it will be acting as a central atom here, and fluorine being a bonded atom, so we will write the electronic configuration of xenon, which is equals to 6s2 6p6, which involve enlace, and valential electron will be 6 plus 2, total 8 valence electron. And since there are 4 bonded atoms, so electron from bonded atom will be equals to 4. Now electron pair will be equals to half of valential electron in the central atom 8 plus electron from bonded atom 4, which will be equals to 6. Hybridization sp3d2 lone pair electron pair will be Here electron pair will be 6 minus 4 bond pair will be equals to 2. So lone pair will be 2. Now geometry will be distorted octahedral. Since geometry is distorted octahedral, so there will be some actual geometry. So its actual geometry is square planar. Its actual geometry will be square planar. Square planar is drawn like this. Now I will compare the octahedral and square planar geometry. So octahedral can be drawn like this. Now I will draw the square planar geometry. Square planar geometry is drawn like this, and two lone pairs are placed above the plane and below the plane. So this is our octahedral geometry and this is our square planar geometry. So if we remove these two bonds in octahedral geometry, then it can easily convert it to square planar geometry.
So thanks for watching this video. Make sure to subscribe the channel and also like, comment in the video.